I've got things started, and I've sent out an invitation. Hopefully those who are logged in will see it. I'll start in just a few minutes.
Hey,
Hello.
how are you guys doing?
Just been lollygagging off over here waiting for somebody to say something, so glad you spoke up, Rama.
Glad. Let me go off the screen so I can still talk to you guys without that.
Oh, but you look so pretty.
That's the problem, man. That's the problem.
It's so distracting, yeah. I guess we can't get any work done.
Yeah, there you go.
It's good to see you, Steven. And Steven doesn't realize he's on mute.
Oh, so how have you been keeping, Chris?
Not too bad. It's been crazy hot over here on this side of the valley.
It's not too bad here. It's dark is showing.
Yeah. And I noticed today my my sprinkler system hasn't been going off in my backyard for a while, and it's because there's a big leak hanging out in the back, so
Mm.
it's been odd and annoying. So are we hearing you, Steven, or are you having microphone problems? I can't hear a word you're saying. Welcome to the show, Daniel.
Hey.
We thought you had abandoned us and just kept sending messages just for the fun of it.
Oh, yes. No, I think I sent a message on one of the
No,
hangouts, but
you did, but I just, you know.
yeah. I had some life issues going on, you know.
It's the same thing girlfriends do, you know. They send you a message and, hey, I'll see you next week. Or I guess soon to be ex-girlfriends.
Oh yeah. In 2 weeks, I'm actually going to be going to North Carolina for a bit, so I probably won't make it for that week. So I'll be gone again.
Oh, that's okay. 2 weeks from now, though, actually, we'll be starting the fun stuff.
Oh yeah, I'm upset now.
So, could be worse.
Yeah.
Uh-oh. I don't know where everybody went. Yeah, Rama is so pretty. Alright, I just sent out a second invitation, so we'll see who else joins us. I think there were a handful. There was at least one new name. I think Mark was going to join us. Max said he was going to join us. Oh, and there actually were two new names this weekend who were going to join us. Somebody said they were in Chapter 5 and just noticed we were out here and wanted to join in, so hopefully they won't feel bad that we're a little ahead of them, or a little behind them, I guess. So,
And chapter 5 is where all the good stuff is starting.
yeah, I've actually kind of started skipping ahead and reading one or two other books. And except that there were so many pages, I almost tucked in the last two sections of Chapter 4 for this week. But then I was worried we would lose 2 or 3 people, potentially. And just as we're getting to the fun stuff, I figured I wouldn't push the issue. So, if I remember, seems like the next section is actually fairly large, or dense in some.
Was that on orders?
Well, it's like the databases, schemas, and it's kind of an applied section, really, more than anything. So,
this is getting into his kind of stuff where he like made all this crap.
It's like 15 pages of, I don't know. I'm half tempted actually to skip this section, because it's the kind of thing authors throw in at the end of a chapter as an applied thing, just in case somebody wants to teach it, and nobody ever seems to. But then you just jump right in, so I don't know. Maybe we should make it optional and see, if anybody cares.
Databases and O-logs. Seems kind of interesting. I guess this is where the sciences part comes in. I don't know.
Yeah, something like that. Yeah, so he throws it in because it fits into the theme of the book. Not that it's a good thing or a bad thing, but so I don't know. Orders is like what? Yeah, maybe we should just bundle section 4.4 and 4.5 and make 4.5 kind of optional. I don't think it's going to be anything too crazy. But there's actually some reasonable math in section 4.4 for those who haven't seen or done it before, and not dealt with it, or who've dealt with it and it's been ages since they've done orders, partial orders. But in my mind, the fun bulk of the work actually doesn't start till chapter 5. So I guess that we can kick things off with a question of, does anybody have any questions about the graphs section. I wish I had Steven's view. That looks like a lot of fun back there.
Yeah.
Yeah, with the bridges. Go ahead, show off. Except you look like you're on the 3rd floor with a bunch of big high buildings behind you, so. I don't know what's going on with his. Yeah, he looks like he's just having too much fun. I wish we could hear him. But I don't know if it's an audio section on his side. He doesn't look like he's muted, so. Oh, yeah.
Oh.
Yeah, I don't see him muted. Oh, look at that.
Hey, you're able to turn the cameras on and off.
Who knew I had the power to actually turn Rama's camera on or off?
That's interesting.
Scary for Rama. Make sure you keep your pants on. So, Daniel, Rama, Steven, anybody have any issues with the graphs section?
There was one thing, I'm not sure if it's an issue or
a question or clarification?
So, on example 4319, this is on page 150. Suppose he wants to spread it out over a discrete time so that each arrow does not occur with a given time slice, but instead over a quantum unit of time. So I'm guessing, also, the only thing I realized from this was it was an infinite graph where you just labeled each one of the arrows as the same as the vertex, or the source vertex. And I'm not really sure what exactly is he talking about when he's talking about spreading it over quantum time and all that. Maybe that's just went over my head. I have no idea what's going on with that. Maybe this is just like an interpretation issue.
Yeah, I think quantum time is, I'm guessing he's talking about discrete time intervals. Chris, can you put on that particular page on the screen?
It's this section right here, right?
Yeah.
Yeah.
Okay. Oh, I didn't know before. Are we on the? Okay.
Yeah, it's quantum of time is actually it's discrete time time units is talking. That's all. I don't think it's talking anything more. I thought that was interesting terminology. Quantum of unit time. Quantum unit of time. Right.
Or is it just like?
Yeah, he's interpreting his time by 1. That's all.
Okay.
That as simple as that.
Yeah.
He's got some fantastic terminology.
I got it.
Yeah.
So I'm guessing it really means discrete rather than continuous or analytic or.
Yeah, he's doing a quantum mechanics that I mean into this.
But he has mentioned quantum mechanics once or twice, I think.
Yeah.
Or maybe that's a different book I'm reading. That's the problem with ebooks. It's much harder to remember what was in what book. Here, I did.
Go on next section, Chris. Next page.
Yeah.
Yeah, this is all time. Next page.
Yeah.
Okay, no, go one page.
There we go.
Not this one, the one before.
Oh, this one?
Yeah. One more before.
Now we're back to where
we
were.
That's where. Yeah. Sorry, stay the same page. The top example was interesting to me because not this guy, man. The same page top example.
Yeah. Oh, come on.
Yeah.
Okay, I'll get it in a second here.
You know how to turn the camera on and off, but I don't know how to control the wrong.
Well, I was trying to zoom into the.
Yeah, when you zoom.
So here we go.
Yeah, this is the guy. Yeah, I thought this was interesting because it took some time to figure it out.
Dirty rat! I did it again.
Yeah, I think you need to keep it in one distance. That's it.
Apparently.
Yeah.
Which page was it? 150, 151, I think.
Yeah, 150.
150.
Yeah, that page. Yeah.
There we go.
Yeah.
Okay.
Yeah, co-product example of A and B, and he's got a. So his examples are very nice, but takes time for me to understand what the heck his intent is basically. Um, it's an interesting example because his source and targets are, and what I thought to be whole graph is really his vertices and his arrows made some interesting. I mean, what I thought were arrows and verses actually didn't turn out the same as what he eventually explained. It makes sense now, but it's a good example. I think I lost your screen first.
Oh, did you? I'm not paying
Yeah,
half
yeah,
attention
yeah,
to.
often, yeah.
Are we
4317.
back?
Yeah, now you can go for it. Yeah,
There we go.
yeah. This is straightforward. I think
This section actually read pretty quick because he had so many nice, pretty pictures that took up
yeah,
so much space.
yeah, yeah. You can go for it. It's all very straightforward.
I don't even think I highlighted anything through this section as weird or odd. Although I've been going back through old sections early in earlier parts of the book reviewing and have to compare against his errata sheet, but I think I found a handful of typos
Okay.
in odd places.
In this section,
Oh, I have a kind of a general question, and it's maybe that I'm just getting used to it and building my sea legs. But how is he reading, or how would one read this section out loud? I mean, I look at it and hum of graph, of these two quantities. And I'm guessing that somewhere in chapter 5 we'll get a better idea of I know what hum set is, and then in the last section or the section before,
Om is homomorphism, right?
yeah. Or
So
I'm
it
guessing it's homomorphisms because he did, homomorphisms both, I think, of groups in the last section and then monoids in the section before.
no, in this section, he talked about graph homomorphisms, and he's just equating them to isomorphically equal to paths, different paths originating at different points
But I guess I'm just trying to,
of different lengths. Sorry, of the group of different lengths.
I don't know, I guess I'm just, it's kind of abstracting the homomorphism of whatever the object is and abstracting that from the two or three examples we've seen to kind of the bigger picture of what's going on.
That's correct.
Um, and I haven't quite gotten there yet, and I'm guessing we'll get there in chapter 5,
I think so.
and it'll make more sense. But I don't know if anybody who's kind of looked further ahead has gotten a better explanation for what that is.
Of the graph
Well, just
homo.
the general concept of the
What he's saying.
homomorphism of whatever the thing is. He started in chapter, I think it was chapter 2. It was hum set, and then very recently in the last couple sections, it's hum monoid and group. I guess it makes more sense to me in the group setting because that's where you see homomorphisms introduced in abstract algebra. And so in that sense, it makes more sense to me there than the concept of hum set as whatever that is.
What he's saying essentially is, you have different paths of, graphs are different lengths, right?
Yeah.
0, 1, 2, 3, and all, and different lengths you can have. So, the homomorphism of the N is your length and G is your graph. If there's a homomorphism between these things, it is isomorphic basically, or same as taking facts. So you need more details. You need to actually go back in the same section to deal with homomorphism. You dealt with homomorphism graphs. You can sort of figure this out.
Yeah. Now, it's been a while since I played around with it, too. Isn't there a structure that's more restrictive than a homomorphism?
Um,
So isomorphism, essentially, the sets have to be the same size, and identities with a function in both directions. And then a homomorphism, essentially, is an isomorphism with the added restriction of the, multiplication in both sets being the same.
Well,
I,
yeah, go ahead. Sorry, go ahead.
I think there might be a little bit off here. The homomorphism is kind of like a more general term than the isomorphism. So an isomorphism is a homomorphism, right? But it's also, you know, uh, has this equivalence relation thing going on with it, where you're basically making them equal almost. So it's kind of, I think, in that sense, more strict.
Yeah. Homomorphism is just, you're right, Chris. Homomorphism need to follow the group operations when you apply a function to that.
So which is more generic then? Is the
more generic,
homomorphism?
okay? And we're using homomorphism when you have one-to-one, on-to type of relation both ways, then you get isomorphism. And a very nice way of thinking isomorphism is you can trade one set to one object to other object and use it equivalently. So you can take left side object or right side object and use equivalently and you get the same results. So, it's in a generic sense that's what a isomorphism is.
In group theory, an isomorphism, you can just define it as a homomorphism which is bijective. So,
yes.
Right? So
Okay.
that's kind of...
Bijective,
yeah. That's probably the better way to think of it.
Yeah.
Or at least for me.
Yeah.
So isomorphisms are in a homomorphism, but it's not, the other way around.
Correct.
Okay. So the isomorphism is the more restrictive
Right.
Yes.
of the two. And is there another one above that?
There's all sorts of
morphisms. Not
morphisms.
remembering it.
Yeah,
there's all kinds of.
There's automorphism.
Yeah.
Which
Automorphism, epimorphism.
Yeah.
They're all coming back to me now.
Endomorphisms.
I'm gonna have nightmares tonight again.
I think those had to do with being, was it onto, or in one of them, automorphisms, if it's the same set onto itself, I think.
Yeah.
Endomorphisms working on same set now, source and destination same set.
Yeah, it's all this topology is coming back, and I'm remembering why set theorists always commit suicide. But I'm guessing some of this stuff comes into play, later on in Chapter 5 when we're abstracting everything out to a much broader level.
Right.
Because the homomorphism stuff keeps popping up, and maybe the kind of, it's just preserving, like, the whatever operation you put on it, at least in groups, right? So, in set with the homomorphism set, I mean, there's not really any operations you can put on it except just a function, right?
Yeah.
So maybe that's just why it's just the set of all the functions between the sets is the homomorphism. But that's just maybe, I don't know.
Yeah. Well,
I couldn't tell you.
What I'm trying to do is figure out the bigger, higher level abstraction for all of these various sets and pieces, rather than, a homomorphism in a group theoretic or algebraic sense makes way more sense to me because I played around with it a lot more, but I guess maybe I haven't played with it as much in a set theoretic or a graph theoretic sense. So I guess, he's leading us down a nice primrose path to see all these examples, and then suddenly he's going to hit us with the, iron frying pan. And we'll be, the light bulb will come on, and suddenly we'll be able to take algebraic topological things and equate them to, quantum mechanical theoretical things. which will be fun at the end of the day. Um, but it's just getting used to remembering which space you're in and what's equivalent in the other space. If space is even the right word to talk about. Category, I guess. Maybe that's the right word. But, we just don't know that yet. All right. What else have you got, Rama?
That's it, I guess. It's a pretty nice section. I wasn't very familiar with graph theory that much. Now there are a lot of surprises for me. What I thought was a graph or a patch versus what he has written out there. So it's a good learning experience.
Yeah, I know. Doesn't graph theory pop up a lot in computer science and optimization problems? At
Yeah.
least with weighted graphs, right? I remember learning something about Dactris algorithm and all this kind of at one point in time in my life. I don't remember it very much anymore.
It does. It does pop up a lot in computer science area. And
So the
surprisingly,
question.
there's a lot of optimization problems associated with graph theory also. Your linear, not linear, sorry, dynamic program problems come in the graph. There's some application graph theory on that.
So does knowing the category theory with associated with graph theory help with the computer science applications?
I'm assuming it all boils down to that eventually because I think the next section is talking database and all that. I'll probably try something down. The reason is just taking this big trip across different domains of knowledge is to perhaps bring everything, tie everything together eventually. Because monoids already appear in computer science in a way, and type theory is now there's a connection between type theory and homotopy theory. So that is there, and so a lot of these things will pop up a lot more in these structures will pop up in computer science. Graph theory is of course pretty central to a lot of things people do in computer science.
Cool.
Oh, I did have one question going back, and I think it was in last week's section. Um, and it's been ages since I played in combinatorics heavily. But he had an orbit of X that he defined. And my assumption based on what this looks like is it's the same type of orbit in combinatorics. Is that right? I meant to pull out a combinatorics book and double check sometime this week, but I figured somebody here might have run across it and know that he's talking about the same things.
I'm not even sure. I haven't actually taken any combinatorics. So if you've done any dynamical system stuff, I feel like it's maybe similar to that also. It's basically just you have an element and you run through how this function acts on it over and over again and just see what happens to it. And you're just following along with it.
Yeah. I mean, I'm pretty sure he is, but the notation he used here seemed a little quirky and odd to me, given the last time I played with orbits and dihedral groups and some of that fun stuff.
I don't know for sure, but I would guess it is the same, similar concept.
Okay, I'll pull it up sometime this week.
Yeah, because essentially, remember this finite sets get mapped to matrices and permutation matrices in the representation theory.
Yeah.
And they have similar structure that they should follow. I don't know. I think top of my head, I don't know, but I would guess it is same.
Oh. And I don't know if it was I'm pretty sure it's not my copy, and it's endemic to everyone. But these sections I've highlighted in gray look funny to everybody, right?
Yes.
The way he types that versus the way he types that sets that. I'm guessing he's going screwy in math mode when he's doing the LaTeX.
Hmm.
and the publisher just didn't pay attention. Not to be nitpicky, but
Yeah, I think you're right.
it's like stuff like that just drives me bonkers. Some of the stuff is hard enough to like pull through without coming into. It seemed like I had one other question from somewhere in the last 2 weeks that I was working through yesterday, but I'm not. I'm not finding it. So
I remember when I was looking at the action tables for monoids, and they were looking at it. They created an action table based on a what was it? A finite state machine.
yeah,
Hmm.
And I feel like whenever I was going through it, they were all wrong. Maybe I just didn't get it, but maybe the multiplication table seemed weird to me. It didn't seem like it was what it's supposed to be.
yeah,
Maybe it's one of the typos, or maybe I'm just dumb. Could be either or.
yeah. Well, it kind of reminds me of, and Rommel will remember this probably 6 years ago. There's some like quantum mechanics for dummies that we worked through that literally had like 3 typos per page.
Yes.
And it literally was so bad you know
We sort of shot it down very quickly.
you really could never tell what the hell you were doing or why because it was just so rife with error. I mean, fortunately, this book isn't. He's got just enough like dispersed across enough space that it's like he's challenging you to know what the hell's really going on.
Yeah, other thing is, in the previous, I think, monoid section, this fellow is defining some arbitrary multiplications. And just to prove a point, it took quite some time for him to figure out this multiplication or not really does make sense because he wants to put some point somewhere. So, so that took me on a bit of a trip out there.
Yeah. Oh, I think I remember that section. The example 41122.
Yeah, something like that. No, something else.
Um, Drove me half bonkers. But I came to the real. Yeah, it was. I think it was so patently off that you knew there were errors. Um, so I noticed Mark joined us. You got any questions, comments, snide remarks, Mark?
Not at this time.
Okay. All right. What else should we check? So I'm looking in the group chat to see if Steven has any questions since we can't hear him. And I presume he would type something in and say something, but I haven't been looking at the chat for a few minutes. The expressions on his face are just priceless, though, without any sound.
So we're moving to chapter 5 next week. Is it true?
Yeah, so we should do. This week we should be reading orders and the databases, schemas, and instances.
Okay.
And my suggestion would be, for those who haven't done this before, not that I'm that much ahead of you, spend more time on the orders chapter, and section 4.5 is kind of an optional thing for the computer scientists, I guess, or the people who want more applied math. So next Monday we'll cover 4.4 and 4.5 so that we can get into the actual real math the week after.
Okay, sounds like a plan.
But I assume that everybody, at least who's with us still, is at least roughly up to speed and that makes sense. Steve says he's sorry he had to find somewhere to plug in, and Guns N' Roses was blaring in his ears. It wasn't his fault, really. But it's been very entertaining to have him here in visual form. So hopefully next week he'll get things squared away and we'll hear the THX 1138 background noise. I'm sure is happening there wherever he happens to be, and he says he's at the Marriott in Brisbane, so looks like a nice hotel at least. Except that you can't smoke outside. So, all right, that's all I got. Daniel,
Hello guys, bye.
anything else? All right.
Yeah, yeah. This one wasn't too bad, I don't think, compared to some of the other chapters or sections, like all the stuff in set.
Yes, the group series, no, not the group, I think the one that bothered me more is monoid stuff.
Yeah.
Yeah. What was the most thorough, going through of monoids I've ever seen in an introductory text?
Yeah.
Most abstract algebra books skip it altogether, at least at the introductory level. Some graduate text throw in a page's worth, but I
Yeah,
don't think I've ever seen 20 pages worth of monoid material ever anywhere.
Right. Usually, I think they just start with group theory and they say, okay, there's this thing called monoid, and we just don't have, what was the other operation?
Yeah, you can't, or actions on one.
There's no inverses, right? There's just no inverses.
Yeah.
That's it.
Do you guys know the difference between monoid and a semi-group? Semi-group?
Semi-groups don't have identities.
No identities, okay.
Yeah. In fact, actually, I was kind of surprised you didn't throw that one as an on mod on a subsection somewhere. But for thoroughness, I guess. So, all right, kids. If anybody has anything else, speak now or forever hold your peace.
Up to next week.
All right.
Okay.
I'll see you next week, Steven. Bye, Daniel. Bye, Mark. I'll catch you later, Roma.